Okay, so we've seen how we can use the first quadrant of the unit circle to evaluate sine and cosine in the first quadrant, but we now want to look at how can we evaluate sine and cosine for angles or for numbers that are not within the first quadrant, so they're not acute angles. We can still use the values in the first quadrant, but we just need to apply what we've learned about uh, terminal points, terminal angles, and their position on the unit circle with our idea of reference angles or reference numbers. Okay, so we're going to work through a few of these, and hopefully that'll help. So first one we want to look at is sine of 135 degrees. So I've already included the first quadrant of our unit circle, and I've included all of our special angles for 0, 30, 45, 60, and 90 degrees, and the corresponding coordinates for each of their terminal points. Okay, so the first thing we need to do for sine of 135 degrees is to figure out where it's located. Okay, so I'm just going to draw kind of a small little graph here. Sine of 135 degrees. Okay, with 135, maybe this might help. 135 minus 90 is 45 degrees. So I know 135 degrees is 90 degrees plus another half of the quadrant. So it is a point on the unit circle that is basically at the 45-degree mark in the second quadrant. Okay, so 135 here. And I then want to find my reference angle. Okay, so how far is it from 135 degrees to the x-axis? Well, the x-axis is at 180 degrees. So what's 180 minus 135? Well, again, it's 45 degrees. So 135 degree angle is in the second quadrant, and it has a reference angle of 45 degrees. Okay, so when we're trying to compute the sine of 135, we could actually use the reference angle, which means we just need to compute the sine of 45 degrees. And then I need to apply the sign, SIGN, whether it's positive or negative, in the second quadrant. So what do we know about whether the trig functions are positive or negative in the first quadrant? So remember, all of them are positive in the first quadrant. Sine is positive in the second quadrant. Tangent is positive in the third. And then cosine is positive in the fourth. Okay, so I already know that because my angle of 135 degrees is in the second quadrant, I know that sine is going to be positive. Okay, and so to get my final answer, I just need to compute what is the sine of 45 degrees. Well, find 45 degrees on the unit circle. Unit's right in the middle of the first quadrant, and sine is the y coordinate. Okay, so I know the sine of 135 degrees will be equal to a positive, because it's in the second quadrant, it's the y coordinate, a positive square root of 2 over 2. Okay, next we need to compute the cosine of 11 pi over 6. Again, the process here is I need to figure out where is 11 pi over 6 located. And we talked about counting around the unit circle earlier in a previous video. But to do that, again, we'll draw a little picture here. And we have to divide the top half of the circle into sixths, and we have to divide the bottom half into sixths. So if we do that, 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6, right? And we want to count around 11 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 pi over 6 is actually an angle in the fourth quadrant. Okay, and if we want to find our reference angle, how far is it from 11 pi over 6 to the x-axis? It is a distance of pi over 6, right? We can just drop the 11 and say it's pi over 6. Okay, so cosine. of 11 pi over 6, we could say is equal to the cosine of just pi over 6, and we just need to apply the sign, whether it's positive or negative. So what do we know about cosine in the fourth quadrant? Well, we already said just a minute ago that cosine is positive in the fourth quadrant. Okay, so this will in fact be a positive value. We just need to compute cosine of pi over 6. Well, let's do that using our first quadrant of our unit circle. Pi over 6 is our 30-degree angle, and we know the coordinate is root 3 over 2 and a half. And for cosine, we want the x-coordinate. So the cosine of 11 pi over 6 is going to be equal to a square root of 3 over 2. All right, so next we want to look at 5 pi over 2. So we need to, again, I'll just draw a little picture, and we need to count around the circle using pi's over 2. So remember, the half of a circle is pi. So pi over 2 is half of a half, which means we're going to talk about quarters here. So 1, 2, 3, and 4. So we're doing quarters of the whole circle, and we just need to count 5. So we're going to go from the x-axis, we're going to go to the y-axis, that's 1 pi over 2, and then to the negative x-axis is 2 pi over 2, which that's the same thing as pi, right? And then we continue from the negative x-axis to the negative y-axis, that's 3 pi over 2. 4 pi over 2 brings us all the way back to the positive x-axis, and so 5 pi over 2 goes around again and ends up on the positive y-axis. So 5 pi over 2 is a point on the pi axis. It corresponds to pi over 2. Right, so 5 pi over 2 and pi over 2 are coterminal angles. So to figure out what sine of 5 pi over 2 is, again, it is the same thing as the sine of pi over 2 because they're coterminal to each other. So we just need to look at the unit circle. Where's pi over 2? Again, it's the 90-degree angle. Its coordinate is 0, 1. And for sine, we go with the y-coordinate. So the sine of 5 pi over 2 is the same value as the sine of pi over 2, and we know that the sine of pi over 2 is a 1. All right, let's do one more here. We want to do the cosine of 210 degrees. I'm going to do the same process. We are going to draw out kind of a unit circle here, and then we're just going to count around. So for 210 degrees, if we started at the x-axis, that's 0 degrees. Once we get to the positive y-axis, that is 90 degrees. So we haven't got to 210 yet. If we keep going, we'll get to the negative x-axis, which is at 180 degrees. We're almost to 210. And if we keep going to the negative y-axis, we'll actually have 270 degrees. So 210 degrees has to be between 180 and 270. Okay, so we're talking about a point down here in the third quadrant. All right, so what is the reference angle for 210 degrees? Well, how far is it from 210 degrees to the nearest x-axis, which would be at 180 degrees? So we could say, what is 210 minus 180? And it turns out that that is 30. So we could rewrite cosine of 210 degrees as a cosine of 30 degrees. Okay, but there's a little bit more again. Each time we've had to account for not only the reference angle, but also the sine of the quadrant. Okay, what do we know about cosine in the third quadrant? Well, all of them are positive. All the trig functions are positive again in the first quadrant, sine's positive in the second, and only tangent's positive in the third. So in the third quadrant, cosine is actually going to be negative. Okay, so my answer, when I'm done here, my answer will be negative. So all we have left to do is figure out what is the cosine of 30 degrees. So if we look back into our unit circle, right, we find our 30-degree angle, which is the pi over 6, and we want to look at the coordinates, right? The terminal point, the coordinates for that point are negative square root of 3 over 2, comma 1/2. And for cosine, remember cosine is the x-coordinate. So a cosine of 30 degrees is a square root of 3 over 2. And so when we get our final answer, the cosine of 210 degrees is a negative, because it's in the third quadrant, a negative square root of 3 over 2.